Good evening, everyone, and I'd like to welcome you warmly this evening to the Pan-African Cancer Research Institute launch. It's really a great honor for me to be the program director this evening. My name is Professor Flavia Senkubuge, and I am the Deputy Dean Stakeholder Relations at the Faculty of Health Sciences here at the University of Pretoria. We have a very exciting program this evening, and I really am really looking forward to it. This is a seminal launch, and I really must say that I decided this evening to dress up because it is a Pan-African launch to have some beadwork, a little bit from Southern Africa, East Africa, North Africa. So if you spot your beads on me, it's really, really just to celebrate you and to really say this is for everybody. And the vision of this Pan-African Cancer Research Institute was really crafted by Professor Dlamini, which is to be a world-class Pan-African Cancer Research Institute dedicated to pursuing the boundaries of precision, oncology, cancer prevention, and bringing new approaches for early diagnosis and novel therapeutic agents to improve health outcomes, reduce health inequalities, strengthen health system in underserved and socio-economically disadvantaged communities. And as you can see, ladies and gentlemen, really, this is a mammoth task that we have set for ourselves. And so it gives me great pleasure then to call upon our Vice Chancellor, Professor Tawana Kupe, to introduce and to really set the tone for this evening. I will read Professor Kupe's bio. It's a very long one, so I will shorten it so that Prof can just get straight into his message. Professor Tawana Kupe was appointed Vice Chancellor and Principal at the University of Pretoria in January 2019. And before joining the University of Pretoria, he held a number of positions as Vice Principal responsible for running the university at Witwatersrand, Deputy Chancellor Advancement, Human Resources and Transformation, Deputy Vice Chancellor Finance and Operation, and Executive Dean of the Faculty of Humanities at our sister university, the University of the Witwatersrand. Prof holds a BA Honours and Master's degree in English from the University of Zimbabwe, as well as a DPhil in Media Studies from the University of Oslo in Norway. And in December 2019, Professor Kupe received an honorary doctorate from Michigan State University in the US and another from the University of Montpellier in October 2021. And really, the CV is so long, and it's a testament to the excellence that Professor Kupe brings with him here at the University of Pretoria. And ladies and gentlemen and colleagues, please put your hands together for our Vice Chancellor, Professor Tawana Kupe.
Thank you, Professor Sekubonge, for that very generous introduction. A very warm early evening. I think I should say it feels like afternoon, but I think it's early evening. This is a great day, as Prof said, to launch a Pan-African Cancer Research Institute. If it wasn't such a painful thing, people dealing with cancer, I would say, cancer, we are after you, and we will get you. I'd like to acknowledge a number of people who are not necessarily in the room or cannot be present at this moment for one reason or another, but will be with us throughout the next 2 days. Dr. Joe Patla, the Honorable Minister of Health, Professor Glenda Gray, the President of the South African Medical Research Council, Dr. Patrice Motsepe, President of the Confederation of African Football and Executive Chairman of a number of companies. Professor Dr. Motsepe's company also does sponsor cancer research in association with the Milken Institute in the United States. International speakers, donors, and partners, all protocol observed. Good evening. May I extend a very warm welcome to everyone gathered here for this auspicious occasion as we celebrate the launch of the Pan-African Cancer Research Institute at the University of Pretoria's Faculty of Health Sciences. With this bold vision to transform the fight against cancer in Africa, By harnessing the power of transdisciplinary research and strategic collaboration, the Institute exemplifies everything which we strive to as a leading African university. And I'm proud and privileged to see this unique platform come to life. Professor Zodo and Dlamini happened to join the university together in 2019, I in January and she in February. So I feel because by virtue of my position, I'm responsible for this, but also much more at a personal level, a partner in this journey. Cancer is a dreaded disease that has a significant socio-economic impact on society. It is the second leading cause of death globally, with cancer rates continuing to increase worldwide. Online database Globocan 2020 estimates that there were 19.3 million new cases of cancer, almost 10 million deaths from cancer in 2020. 70% of cancer deaths occur in low and middle-income countries like ours and like our continent, and cancer is also emerging as a major public health problem in sub-Saharan Africa. Given that the disease has been given a low priority in the research field and in healthcare services across the continent, there is a shortage of epidemiological expertise, research resources, and medical equipment in Africa. So the launch of PACRI is more timely than ever. A world-class Pan-African Research Institute dedicated to pushing the boundaries of precision oncology, cancer prevention, and bringing new approaches for early diagnosis and novel therapeutic agents to improve health outcomes, reduce health inequalities, and strengthen health systems at dire need on our continent. In underdeserved and socioeconomically disadvantaged communities, PACRI is perfectly placed to reduce the future burden and suffering from cancer in Africa and worldwide. The Institute's three key macro research areas include clinical cancer research with the goal to advance early detection, treatment as well as personal care by selecting emerging therapies and strategies to offer patients as experimental alternatives to routine care. Now, traditional cancer research, creating to quote, from bench to bedside and back again, close quote, delivery continuum, by facilitating the movement of new ideas and treatments from the laboratory to the clinic, as well as the movement of clinical observations from clinic to the laboratory. And population and prevention cancer research, working to improve survival outcomes with activities in cancer epidemiology, prevention and control, as well as collecting detailed lifestyle information and biospecimen in search for risk factors and biological mechanisms to address gene-environment interaction in cancer etiology. Given such a comprehensive mandate, PACRI's relationship with bilateral partners and international cooperation is absolutely vital. Funded by the University of Pretoria, the South African Medical Research Foundation, and the National Research Foundation, NRF as is known, together with strong cooperation from the South African government and its entities, the aim is to consolidate existing cancer research efforts and resources to provide a platform for research growth and development throughout South Africa, as well as internationally, and of course on our continent, Africa. As founding director, Professor Zodo Dlamini explains, while there are currently pockets of excellent cancer research or sites of excellence, if you like, in South Africa and the sub-Saharan region, cancer researchers still believe in working in silos or in isolation. Even within the same institutions, basic scientists work in silos and clinicians work in silos. And so PACRI capitalizes on the opportunity to form multidisciplinary teams working under specific themes. As a university in general, let me say, and the facility you are present in here is, we believe in inter or transdisciplinary research, the intentional, strategic, deliberate breaking down of those silos to provide better outcomes. This knowledge sharing will strengthen outcomes significantly, allowing physicians to allocate research expertise more effectively, as well as helping to identify multiple researchers who may be able to contribute to the understanding of precision oncology. Strengthening existing relationships and forging new partnerships will be an ongoing priority. In line with PACRI's slogan, defeating cancer together, collaboration is at the very core essential for the Institute's success. Synergies with existing programs is critical in order to strengthen efforts of resource mobilization and targeted capacity building through national, continental, and international support, including promoting effective public-private, and civil society partnerships. PACRI's positioning as a center of excellence gives it a unique opportunity in the international environment to attract much-needed investment to African health and well-being. The serious skills shortage in cancer research in South Africa and Africa means that training is imperative. Without this capacity for country-led development, will remain limited, and so PACRI will focus on identifying new partners willing to contribute to its skills development programs. A major strategic goal is to double the funding capacity in order to expand the PhD and postdoctoral fellowship programs, important as a pipeline, as you know, for future researchers and for future expertise and experts in cancer research, and as well expanding postdoctoral fellowship programs, increase the number of international exchanges, and specifically target women scientists, because in that domain as well, the bane of gender inequality is still with us. There is also a strong need to conduct more practical training courses across PACRI. There is currently a team of experts with the PACRI International Advisory Committee who work in the cutting-edge area of cancer research, and they bring the skills required to help in building several future cancer researchers by co-supervising, for example, PACRI postgraduate students, or even supervising or mentoring postdoctoral fellows, and of course, early career researchers. Excitingly, the building of the state-of-the-art of PACRI laboratories should be completed by the end of 2022. I'm inviting you to the ribbon cutting ceremonies. I luckily will have the privilege of holding the scissors, but if there are better people than me, so be it. This includes the Biospecimen Core Laboratory, the Biostatistics Core, and a preclinical research core dedicated to cancer research, along with the first whole cancer genome and transcriptome sequencing facility in Africa that will be absolutely really cutting edge, providing state-of-the-art resources to African researchers studying the human genome and cancer. As a university, we've very much embraced our continental identity. We're not just a South African university. We are rooted here and we're deeply committed to the development of South Africa. But we're also continental. We're part of the African continent. After all, South Africa is the only country on the continent that carries the name Africa. This is Africa. I'm saying that cheeky. And are passionate about Africa's unbelievable richness in terms of its people, natural resources, cultures, biodiversity and environments, and people of ideas, and its potential to thrive as a knowledge economy that relies on itself for solution to its own challenges. We are also aware that the future of the world hinges on the future of Africa. This is because Africa's population of more than 1.3 billion will double by the middle of this century, potentially rising to 4 billion people by 2100, or around 1/3 of the world's population. It is also the youngest population, so we have a unique opportunity to upskill a generation that can tackle the world's complex problems, and apart from Africa's own needs, contribute high-quality human resources to those regions of the world which have an aging population. Cancer is one of the numerous crises which we are navigating in these disrupted times. What is clear is that these challenges do not come nearly packaged to fit into silos, boundaries, and borders. They've certainly required us to holistically rethink, reimagine, and reposition our broader role in society as universities. I'm here talking about the very fact that it is not longer good enough, was never good enough, that we're simply proud of our academic and research excellence measured in academic metrics, important as they are, H indexes, citations, medals, and even sometimes Nobel prizes. Those are very important markers of excellence. I do not deny that. But we need to do much more to make sure that that excellent knowledge translates into transformative impacts in society. I'm thankful that the emergence of transdisciplinary research methods has offered a unique opportunity for universities to take the lead in creating new knowledge and new ways of doing things. And I'm thrilled at how PACRI is a living example of this powerful possibility. We anticipate great things as different forms of knowledge stemming from a broad group of area specialists come together to solve complex problems and improve the health of our people, both now and in generations to come. I thank you.
Thank you very much, Professor Kupe, for that powerful presentation and for giving us really the clarion call to do more, to be more, to break down the silos and to recognize that our problems are complex, and not only are our problems complex, they actually need us to have a multidimensional and also a multi-skilled approach in terms of approaching them. And with that, embracing our collective intelligence and leveraging not only in terms of our intelligence in our own country, in South Africa, but really working together with other partners in the continent and also with partners globally. And without much further ado, it then leads me to introduce someone who really needs no introduction in our medical spaces, Professor Glenda Gray, who is the CEO and President of the South African Medical Research Council. And I will just read a short bio of Professor Gray. She is an NRF A1 rated scientist. And for those of you who may not know what that is, that's one of the highest honors that the NRF can rate you as a scientist. And it takes a lot of work to get to an NRF rating of A1. And prior to her appointment at the South African Medical Research Council, Professor Gray was working at the Perinatal HIV Research Unit as its executive director, and many of you may know it as the PHRU. Professor Gray is a recognized leader really in her field, and she has been selected as one of Time's most 100 influential people. This evening, Professor Gray will be joining us virtually, and she will be presenting, and the title of her presentation is Cancer in Africa is a Developing World, Strengthening Funding Streams and Ties to Defeat Cancer. Over to you, Professor Gray.
Thank you very much, MC. Our host, Vice Chancellor and Principal of the University of Pretoria, Prof. Tuwani Kupe, the esteemed panelists, Professor Zodwa Dlamini, all protocol deserved, all protocol observed, deserved. Yeah, all protocol is deserved. Thank you very much. I'm going to just say a few words about the MRC's interest and investment in cancer. So the reason why the MRC is interested in investing in cancer is that we see that there is an increase in incidence and mortality, and cancer has been given a low priority in the research field in Africa. And this also has related into also a low healthcare priorities as well at a continental level. As the VC said, about 50% of all new cancer cases around the world occur in low and middle income country settings. And this is because of lack of awareness, lack of prevention strategies, and also increasing life expectancy, so more cancer will emerge the moment people's lives are extended or the increased survival in low middle income settings. We know that statistics about cancer in Africa are dispersed in many registries, and there's a lack of cohesion in us in being able to understand the epidemiology of cancer and the true burden at a continental level. The prevalent cancers we see in North Africa are breast, bladder, and liver, and in South and East Africa, it's prostate, lung, colorectal, cervical, and esophageal cancer. And particularly in Southern Africa and South Africa, we know that esophageal and cervical cancer play a big role in increasing mortality in both women, cervical cancer, and men, esophageal cancer. We also know that there are special epidemiological and genetic predispositions to certain cancers that we need to focus on. So given the increased incidence of cancer, we also have seen that we haven't really impacted on improving mortality rates in cancer. And we need to emphasize that as a way going forward. We need to augment the research and epidemiology of cancer in Africa and look at preventive and therapeutic interventions. So we do know that at a continental level that population, origin, and diversity are influences of cancer and survival, of drug response and molecular pathways. And we know that most genetic and epidemiological cancer studies and discoveries have been reported in non-African populations, especially those of European descent. Mostly our continent has focused on communicable diseases like HIV, malaria, and TB, and we haven't focused on non-communicable diseases. And as we increase life expectancy, we are seeing an explosion, a new epidemic of non-communicable diseases, and obviously cancer is one of them. We also know that a lot of cancers in Africa have viral origins, and things like HPV, which causes cervical cancer, could be easily prevented if we paid attention to a wide-scale application of HPV vaccines in both girls and boys on our continent. And in the last 5 or 6 years, we've seen a decline in HPV vaccination at a continental level, and a shortage of HPV vaccines because of the increased use of HPV vaccines in young boys across the high developed, across high resource countries. So something to improve. So the MRC has invested, because of the lack of genetic understanding of cancer in Africa. We have focused our attention on developing whole genome sequencing capability in South Africa and established the first whole genome sequence for South Africa at the MRC, so everybody can use it. We've also invested a lot in precision medicine and in precision diagnostics with an emphasis on cancer. We know that we also know that we have to invest in cancer centers and have emphasized epithelial cancer and cervical cancer as part of our program, as well as looking at colorectal cancer. We have also invested in both population and pathology registers, which are important in managing and tracking cancer as we go along in the world and in South Africa. And we're also interested in doing this in the spirit of open science. And so all the research that we fund, we want to see this we want to see collaborators sharing data, sharing information in the spirit of good collaboration and open science. The MRC has had a long journey with Zodwa Dlamini, the Professor Zodwa Dlamini, and only a tenacious woman like her could achieve this wonderful program. When she first told us about her vision of having a Pan-African cancer research institute, I loved her passion and her ambition. And however, was a little bit skeptical about whether she could achieve this. But Zodwa never ever fails to surprise and get me excited, because she is a dedicated, passionate, and wonderful scientist that believes in a transdisciplinary approach, and she has unrelentingly moved forward to achieve this vision of the center. And from coming from various universities, putting her mind to this institute, getting funded to become a mid-career scientist, to becoming a center funded by the MRC. All I can say is that she deserves to lead this program. And something like this will be successful because of the determination, tenacity, and brilliance of Zodwa. So Zodwa, I'm going to see you tomorrow, and I'm very excited to be there. And I'm very proud to be there as well, because this is your vision, and you will be a huge success. And the MRC looks forward to a long-term collaboration with you and funding the programs that you do. So congratulations, and I'll see you tomorrow.
Thank you very much, Professor Gray. And it's of course not lost on me that Professor Gray, at her conclusion, is really highlighting the role of women scientists and the drive and the passion with that when they are given space, they do lead and they do take up their place. And it's really an agenda that is very much at the heart of our Dean, Professor Tian Diache, in terms of ensuring that the next generation of leaders, particularly women scientists, are at the forefront of leading programs at the University of Pretoria. Colleagues, it gives me great pleasure then to welcome Professor Dave Bates. As I said, this particular launch is not only focused on the Africa region, but is focused on our friends and partners globally as well. And Professor Dave Bates is one such person. He's the director of the University of Nottingham Centre for Cancer Sciences in Nottingham in the United Kingdom. In 2013, Professor Bates was appointed as chair of Division of Preclinical Oncology at the University of Nottingham, and he founded Exonate Limited. So remember, scientists, you can found companies. And that was based on his co-discovery of new potential drugs for modifying mRNA alternative splicing in disease, and he continues to develop new therapeutic avenues for cancer and also other conditions. His academic research investigates anti-angiogenic and immune approaches to cancer. His research, he collaborates quite widely with a number of our sister universities, and he collaborates globally working on cholangiocarcinoma, for those of you who will remember it in our books. So Professor Bates works on that, and he's worked on cholangiocarcinoma and other cancers in Thailand and Laos at Mahidol University in Bangkok, as well as working on colorectal cancer and other cancers here at home at the University of Southern Africa, UNISA. He's also acted as a scientific advisory board member for the South African Medical Research Council. And I do want to add that in 2001, he was awarded a BHF lectureship, and he then established the Microvascular Research Laboratories. And this evening, Professor Bates will be talking about the value of cancer institutes or centers for precision medicine in cancer prevention, early diagnosis, and treatment. Please welcome Professor Bates.
Thank you very much. It's a pleasure to be here. It's a real pleasure to be here to support the launch of the Pan-African Cancer Research Institute. I've known Zodwa for a long time. We first met at a conference in the US where we discussed the biochemistry of cancer. And over the last few years, we've talked lots about how we can try and change the molecular biology and understanding of the cell biology of cancer to actually affect the outcomes for cancer patients. And it's quite a long journey to go from the cell to patients. And it means that you need to approach it from a very interdisciplinary viewpoint, as the Vice Chancellor was talking about earlier. Having listened to what Glenda's just said, I think she's covered most of the first half of my talk. But I'm going to focus particularly on why cancer is such a problem in Africa and across the world, and why the approaches that we need to use to address these issues need to be local. They need to be specifically tailored and driven by the particular areas in which they're looking at. So if I can just move on, for many years, cancer was considered to be a high-income country problem. a problem that was driven by age and a lifestyle that was not portrayed throughout the rest of the world. But cancer is a huge problem across the global south. It's a huge problem in low-income countries, and to an extent it's getting to be a much bigger problem. And one of the reasons for that is that the different types of cancer that you get across the world vary from place to place. And in fact, most of the cancers that kill people in the global south affect younger people. They affect people who are under 70. Most of the cancers that affect people in places like the UK and in the US are ones that affect the older generation. If you look at this map here in red, we've got a higher incidence of cancer in those under 70 years old. The more red it is, the higher the incidence. And you can see it's not the US and Europe that has the highest incidence of cancer in the under 70s. It's actually the eastern part of the world and Africa. And in fact, if you start to look at younger populations, if you look at those between under 55, you find that actually Africa has a massive problem with cancer. It's much worse for the under 55s in Africa than it is in many parts of the world. And in fact, as you go younger, in the under 35s, you see that Africa is a major a major place where cancers kill people. So the cancers that you get here are different from the cancers you get other places in the world, not necessarily because of their location, but because of the way they behave. And the data that we use to generate this comes from a consortium called Globocan. And that data itself is also an underestimate of what happens in cancer. And I'm going to give you an example from an area I work quite closely with in Laos and in Thailand, and that is particularly for this cancer cholangiocarcinoma that we talked about a minute ago. This is a cancer of the bile duct in the liver, and it has a very high incidence in northeast Thailand and Laos. Now, interestingly, the official death rate for Laos is about 48,000 people, about 7.1% of their population each year. Recorded death rate of about 5.9%. And the major causes of death are thought to be influenza, pneumonia, coronary heart disease, stroke, dengue fever, and so on. And you'll see that liver cancer is down here at 6th. In fact, liver cancer is much rarer than that. Liver cancer is not the same as cholangiocarcinoma, but almost everybody who has cholangiocarcinoma when they're recorded as having liver cancer. That's because the Laotian health system doesn't allow for a separate diagnosis of bile duct cancer. But if you go out and sample randomly across Laos people and look for bile duct cancer, the incidence is somewhere between 0.1 and 1% of the population. And this is a very nasty cancer. From diagnosis, even if you go out and you scan people, the diagnosis is the survival of this cancer is about 12 months. This is one of the most lethal forms of cancer you can get, which means we should be seeing a death rate somewhere between 8,000 and 68,000 per year. And yet the official statistics are somewhere under 2,000. Why? And one of the reasons for this is that people who have cholangiocarcinoma don't go to hospital. They go home to die. And they're recorded as dying with a fever. So most of these influenza and pneumonia cases are not influenza and pneumonia. They're people dying of cancers, but it's not recorded as such. And that's just for cholangiocarcinoma. This is also true in Africa. So where do they get these statistics from? When you actually go and look at where the statistics for cancer deaths come from, they don't even come from Laos. The source of the data is that there is no data, and the rates that are provided are those from neighboring regions. Now, in Laos, you get cholangiocarcinoma because of the diet you have. It's caused by an infection with flukes. You don't get that infection if you live in most areas of Vietnam or most areas of Thailand or in Burma. So that particular area of the world has a disease that's driven, which is specific to that country, and there is no data collected. This is not just true of Laos, this is true of many parts of the world. So the data that's there isn't even reliable. So what's this got to do with Africa? Well, if you look at the major causes of male deaths of cancer that's recorded by Globocan and most statistics in Africa, you see that it's generally thought to be prostate cancer across most of southern Africa and lung cancer in northern Africa, although there are some areas where other particular types of cancer are important. So in pink here you see the most common cause is Kaposi's sarcoma, which is driven by HIV. So these common causes of cancer are, again, often taken, for instance, in the Congo, there is no data. That data is taken from other areas around. In fact, most of the African prostate cancer is the killer comes from data from Kenya and Uganda. So we need better databases. We need better understanding. We need better data that drives what we do and the health care provisions that we provide. And the molecular biology that we do needs to be able to be tailored for those particular areas. Botswana is an interesting example. Botswana, the top 10 causes of death in Botswana are there, and you see that there is no cancer there at all. So why would you do cancer research in Botswana? People don't die of cancer in Botswana. The top 10 causes of death don't include a single case of of cancer. The source for this is the GBD compare data, but when you dig into that, what you see is there is actually something very strange going on here. Because this only accounts for 68% of deaths. Where's the other 32%? The leading cause of death is HIV, which is about 25%. And what you see is when you look at the overall survival of life expectancy in Botswana over the last 50 years, what you see is that the HIV epidemic decimated the life expectancy in Botswana. And this is also true in lots of other areas of Africa. This is just as an example. But you'll see that since 2000, that has bounced back enormously. And the life expectancy in Botswana is now around about 70. Now, if you get to 70, you've got a very high chance of getting cancer. So where are these cancers? They're not showing up. In 2019, they're not showing up in the top causes of death. Well, this is the breakdown of deaths in Botswana. And you can see, of course, HIV is still a major cause. But this is cancer highlighted in yellow. They're broken down by individual types of cancer. You don't break down HIV by the different ways that you die of HIV. You don't break down stroke by the different ways that you get a stroke, whether it's a occlusive stroke or a bleeding stroke. But the different ways of cancer are broken down into different areas. Actually, as a whole, cancer forms about 12% of deaths in Botswana. Is the second biggest cause of death in Botswana. Now, this is Botswana. What about Africa? Oh, by the way, malaria is that tiny little box down there. And for many countries, malaria is a bigger killer than it is in Botswana, but it's still, compared to cancer, in many places not comparable. If you look at, but that was all deaths. So that includes neonatal deaths, includes children dying in childbirth. If you look at the older population, and now think we've got a 70 average life expectancy. If you look at 50 to 69-year-olds, about 25% of Botswanans die of cancer between 50 and 69. So the cancer incidence and the cancer prevalence in these groups is much higher. This is for South Africa. This is now not Botswana. This is South Africa, and you can see cancer deaths are more than 25% in South Africa, counted together. Now, what's also interesting here is that on the right-hand side in red, you see communicable diseases, and these communicable diseases are being reduced in their incidence drastically in the last 10 years, and are going to continue to be reduced in their incidence. Again, this is Botswana. I'll show you the South Africa one in a minute. On the left-hand side, in your left-hand side in red, is the change in incidence over the last 10 years. And in red, you've got communicable diseases, and in blue, you've got non-communicable diseases. And what you see is that the communicable diseases are becoming less incident, and the non-communicable diseases are becoming more incident. In other words, we're switching in Botswana, but also in South Africa, away from communicable diseases towards a non-communicable disease. And that trend is only going to continue. And cancers take a long time to happen. And that incidence of cancer is not something that's happening that's happening now. It's something that's happened over the last 10 years. And that means what we're going to see is this increase in cancer incidence over the next few years. So if you take out HIV and you take out TB from these, or at least reduce the number of patients dying from this, you start to realize that cancer becomes a much more significant cause of death. And as I said, just as in Laos, in other areas of Africa, cancer deaths are massively underestimated. This is leukemia. There was a very interesting study looking at what happens if you randomly sample people in Uganda for pre-leukemic incidents versus you randomly sample UK people. And what you find is that in the UK, they have, oh, sorry if I can go back. In the UK, the percent of people with potential leukemia is actually lower than it is in Uganda. But the people with actual leukemia is much higher. But the conversion rate is no different in Uganda from it is in the UK. And the reason there is that when people in Uganda get leukemia, they die of infection. And they die of an infection way earlier than they would do in the UK. So their deaths are recorded as infectious disease deaths. But actually, it's not the infectious disease that killed them. They would have survived that infectious disease if they hadn't had the underlying leukemia. So this happens across the world, but particularly in the global south. So these cancers that we see, that we think are killing us, aren't necessarily the ones that are being focused on from the right area. They're being focused on by the people in the UK and the US who are looking at the data. It really needs embedded indigenous researchers to look at their own countries, their own ways of dealing with things. What happens to society when you get cancer? What is the social contract that you have with your family when you get cancer? In Laos, you don't go to the doctor if you've got bile duct cancer because there's nothing you can do about it and it will bankrupt you. You go home to die. That means you need to look at doing things in a very different way. We need to come up with different solutions for different parts of the world. For women in South Africa, as Glenda said, the incidence of cancer and the cancer development is completely different from in places like the UK. What you see is that cervical cancer has a much higher incidence, and we can argue that may be to do with vaccination or HPV infection. Actually, it's not. The vaccination for HPV in the UK is only just beginning to have an effect on on cancer deaths from cervical cancer. It is beginning to have an effect, but we've been vaccinating for about 15 years. And HPV takes a long time to develop cancer. The real difference is that the incidence of HPV infection is lower. The incidence of safe sex in the provision in the UK is higher than it is in Africa. It's actually preventative mechanisms that are happening that make the difference. And those two things can affect how cancers happen. So again, local solutions are really important. The cancers that you get here are different from the cancers that you get in the UK molecularly. And you can tell that by looking at the course of the disease of patients with cancer. People with breast cancer in South Africa tend to be much younger than people with breast cancer in the UK. They tend to have much more aggressive cancers than they do in the UK. That tells you that the cause is different. Now, we don't really know what the cause of breast cancer is, apart from some small proportion of people where it's genetic. Clearly, alcohol has some relationship. We think now there's a link between HIV infection and breast cancer. But we need to understand what are the driving factors behind this. Cervical cancer in the UK is thought to be very much associated with HPV in the same way that it is in Africa, but it's clearly not only that. There are other viral loads that make a difference. So understanding those causes is going to be critical, and you can't do that simply by looking at the cellular and molecular biology. You have to involve sociologists, you have to involve social policy people, you have to involve epidemiologists. You need to be interdisciplinary about how we do this. And then we have a really interesting question about what the impact of COVID is going to be. The impact of COVID may be absolutely disastrous. We have our undergraduate students come in to do a cancer sciences course in Nottingham, and we asked them at the open day, does COVID cause cancer? Does it? We have no idea. No one is going to know whether COVID causes cancer for 20 years. There is good molecular mechanisms through which it might increase the risk for cancer. In a significant proportion of people who've got long COVID, they may have very high risk of lung cancer. We just don't know. It might be disastrous. But there's lots of things that have come out of COVID which may be helpful for cancer. For instance, the development of new vaccines that have happened. A lot of them are actually repurposed cancer vaccines that have now been shown to work. And we can now go back and use them again in cancer in vaccines. A beautiful study that's been going on in terms of looking at using COVID swabs to determine HPV infection in vaginas in women's vagina when they've got when they can do the test at home. Send it in. You don't need to do a smear test. You only need to pull in the people who are HPV positive. That could massively change our screening programs for cervical cancer in the UK, and it could massively change the way you do screening cancers in Africa. So there may be some good things that come out of COVID. There may be some really bad things we don't know. So most cancers are preventable. Life causes cancer. The older you get, the more likely you are to get it. The more exposure you have to antigens and to cancer-causing agents, the more likely you are to get it. And that means that we can do things as a society to prevent people getting cancer. And public health initiatives are critical. And there are some of the biggest research programs and most effective anti-cancer programs that have come about not because we understand the molecular biology, but because we understand people's behavior. The biggest change in lung cancer rates came because we stopped smoking in public. It didn't come because we developed a new drug that would treat lung cancer. So public health is important. Education is important. More deprived people are more likely to die of cancer. Even if they're the same likelihood of getting it, they're more likely to die of it, but they're not more likely. They are more likely to get it. We need to be revisiting vaccination. We can now vaccinate against a number of different cancer-causing agents, and we are now beginning to be able to vaccinate against cancer itself. And this is all going to require an educational program which involves every level from primary school through to higher degree level. Changing policy has been effective in the UK for a few things. It's been effective in Europe for a few things. It's been disastrous for others. We've been very good at reducing lung cancer by smoking. We're reducing mesothelioma by improving workplace safety and removing asbestos. Radiation protection events. There are things that you can do that can be done in South Africa that are very important in terms of social policy that can be done. We still have appalling drug access in most of the developed world. In America, drug access is a huge problem. In the UK, it's still a problem. It's not as big a problem, but it's still a big problem. Inequality is a huge problem in the UK. We have massive differences in equality where we have not been able to address this, and cancer survival rates in some areas of the UK are absolutely appalling because the public policy hasn't done anything about it. So changing policy is really important, but in order to change policy, you need to know what the problem is. And in order to know what the problem is, you need the science that underlies that. And a lot of that comes down to early detection and being able to screen. And essentially, most of our current screening mechanisms involve looking at tissue or looking at stool samples or blood samples or sputum samples and looking for known markers, blood in the stool, cells in a smear test, and so on. Once that happens, you then get sent for imaging, which is expensive and difficult to do. Most of that is done by, in the UK, PET scanning, CT scanning, and MRI, some ultrasound. Over the next 5 years, and certainly over the next 10, we're going to see an absolute explosion in liquid biopsies. We're going to see circulating tumor DNA, autoantibodies, extracellular vesicles, metabolomics being used to be able to pick up cancers in people as part of their routine healthcare checks. But that is going to require them to then go and get that cancer imaged, which means there's going to be a huge demand for radiography, a huge demand for radiologists to be able to capture those images and determine whether or not they're able to be used to determine cancers. And that means new types of imaging systems. And we're seeing new imaging systems coming through, things like arterial spin labeling, MRI, which are going to be able to pick up much smaller cancers much more effectively. And one of the things that we're now seeing is an explosion of artificial intelligence in that in the reading of that imaging to be able to identify large numbers of patients without cancer, because most of these people who are going to get sent for imaging are going to be negative. And that means that we need to have experts that can seed those areas of development. And that's the real value of cancer centers. You bring together a collection of experts who can work together to explode the advances in knowledge in that particular area. But that means that you need to look for an interdisciplinary network. It needs to be a network which can integrate science, the clinical work, population and social policy across the whole units. It needs to be somewhere where patients can go. So it does need to have to be linked into the hospital and the healthcare system. And it needs to be able to link into national and local governments. It needs a coordinated program. We need to be able to say, okay, what is our outcome for success? How does it embed within the community? I would love to see in South Africa more of an engagement of the hospitals and the universities in the communities that they are there to serve. I believe there is only one university that's that's in a township in South Africa. Where are those bright young things coming through there going to see themselves if they don't have those universities as part of them? We need medical schools in the townships as well. So these centres are able to coordinate that support to support devolved research, to allow people to get on and do their own research, to be able to come up with those new ideas from the ground up, and to engage with their communities so that those ideas can come out from their communities. Public-patient interaction is an absolutely critical part of this sort of research. And the centres can act as advocates. They can act as advocates for government, they can act as advocates for the patients, they can act as advocates in industry to be able to take these areas forward. I've gone away over time, I'm sorry, Zodwa. But it all depends upon access to high quality doctors. And that means training. It means training not just medical doctors, it means training physiologists, it means training pharmacologists, immunologists, biochemists like Zodwa. It needs universities to be able to get together to train these people. And that's really, really critical. In Nottingham, what we've done is build a cancer centre that tries to incorporate this, where we have undergraduate, postgraduate, postdoctoral and academic training all the way through, so that students come in and learn about cancer science as an undergraduate program. It's the only undergraduate program in cancer sciences in the world. They can do a master's in oncology, a master's in cancer immunology and biotechnology and so on. They can do PhD programs. And the academics themselves have support in their growth and their ability to interact with the public and industry. And we believe this is a good model for people to adapt to their own programs and see whether they can take those forward there. So just key take-home message. Cancer is a policy decision. It's possible to get rid of most cancers. It is a clear political policy decision about whether or not you allow people to die from cancer, and particularly whether you now allow young people to die from cancer. And by young, I'm now including myself, so anyone under 60 counts as young. Cancer centres are critical for generating sound scientific advice for those policy decisions. In the UK, we have this government statement of, we'll follow the science. Well, we don't believe you. But at least you have it. It's your decision if you have the science. If you don't have the science, you can't follow it. You can avoid cancer killing younger people, but we need to look at prevention. We need to look at early detection and diagnosis. We need local solutions to local problems, because the solutions that come up from one country or one part of the world may not apply to another part of the world. And we need to understand the causes and consequences of the cancers that are killing people here and now, and the causes and consequences of cancer that are going to kill people in the future. And in order to do that, we need training and we need education. Thank you very much for your time. I hope that I haven't gone over too much of what Glenda said. But thank you very much, and I'm happy to have a discussion afterwards. Thank you.
Thank you so much, Professor Bates. And I do have to say that as a professor in public health medicine, I was smiling from ear to ear under my mask, especially when you talked about social policy, and that cancer is indeed a policy decision. And I really got excited about that. And of course, your articulation, again, re-emphasizing, colleagues, everything that's been said this morning: interdisciplinarity, transdisciplinarity, collaboration, coordination, and most importantly, again, another call that as institutions of higher learning, there is this lens of community engagement that we certainly need to focus on. So thank you so much for that. And without much further ado, then, colleagues, our next presenter is Professor Michael Bowman. And Professor Michael Bowman is the director of the Krebs-Foch-Fontaine Centrum, and we know it as DKFZ in Germany, and that's the German Center for Research in Cancer, and it's in Heidelberg in Germany. And Professor Bowman received his habilitation in radiation oncology. In South Africa, would call it his specialist qualification at the University of Hamburg in Germany in 1994, and his MD at the University of Hamburg in Germany in 1988. The research program of Professor Bowman as a radiation biologist and radiation oncologist really is dedicated to translation-oriented experimental radiotherapy and radiobiology. And this includes therapy of molecular targeting and biological imaging for radio-oncology, with a special focus on the treatment of lung, head, and neck cancer. He has a number of awards. He's a member of the supervisory board of Charité Universität Medicine in Berlin since 2020. And Professor Bowman, I must say, I have visited Charité, and it's just absolutely beautiful. And Berlin is a lovely, lovely city and one of my favorite cities. He's also the advisory committee member of what they call the HI-STEM GGMBH for the DKFZ since 2016. He's the co-chairman of the strategy group on the National Decade Against Cancer, and that is since 2018. And he's the chairman and scientific director of the DKFZ. I read all of these things, colleagues, because we do have younger researchers, Professor Bowman, so that they can see the kind of work that all our people are doing. And so over to you, Professor Bowman. Thank you so much.
Thank you very much. And it's a great pleasure to be invited by you, distinguished colleagues in Pretoria, today for your launch of the Pan-African Cancer Research Institute at the University of Pretoria, which is a wonderful endeavor. I will share my desk and hope that you can see my slides. Wonderful. So let me briefly start with DKFZ, which is the largest biomedical research institution in Germany and the largest cancer research institution in Europe. So one particularity of our research in Heidelberg is that we have connections, although the main center is located in Heidelberg, that we also have branches and connections with a number of university medical centers all over Germany, and that for the last 10 years, we have formed very powerful networks which go together to fight cancer. If we want to get rid of cancer, we have to think about strategy. And here is my summary of what a strategy against cancer can be. So first of all, although we know a lot about cancer, we also have a lot of things we don't know about cancer. So we have to further increase knowledge by research. That research and that knowledge then can go into three big innovation strategies or innovation pipelines. One is on prevention, and we heard wonderful lectures already about the value of prevention in cancer, which I fully support. The second big strategy is also prevention, secondary prevention, but for better understanding, I call it early detection. And only the third is more effective treatments. All three are of enormous importance. The focus for many, many years has been more on effective treatments, which I think is wrong. We have to focus on prevention and early detection as well. If we have developed new strategies, then we still have to implement them into the health system, and health systems are different all over the world. We have to monitor the outcome, and we also have to prove added value. It is very clear from our understanding of cancer today as a very heterogeneous and very complex disease that the future needs personalized oncology approaches. And personalized oncology is not only covering more personalized treatments, we also need personalized prevention and personalized early detection approaches, and we have to develop them by research and prove them in a clinical research setting. Because data are increasing, and also that point was already made, but tremendously increasing in cancer research and in cancer care, we need to invest in data science. And last not least, and that's my topic today, we have to have a global view on cancer, because cancer is so different in different parts of the world, but cancer also doesn't know borders and goes beyond borders in all of our countries. So having said that, in our center, we included these different points in our mission. So our mission is shown here. We will contribute significantly to decrease new cancer cases and cancer deaths through transformative research, education of the next generation of leaders, and transfer of our results into the health system, society, and innovative products. And we do that in our center in, I will not go into any detail here, we do that in different sections. All of these sections include approximately 300 scientists. And to pick only one, let's say number 5, imaging and radio-oncology, all of our sections go from fundamental basic research that in the field of imaging and radio-oncology is medical physics, radiobiology, and fundamentals of physics and biology. And we take it up to research on patients. So we have a full translational chain in all of the research efforts we do. And we are also not working in silos, so to say only in imaging and radio-oncology. We connect these fields to other fields which we do research on in our center, for example, number 2, functional and structural genomics. We have horizontal issues we approach together, and cancer prevention and early detection is one of our big horizontal programs. To give you a flavor of some of the innovations and some of the research which came out of my center, the HPV vaccination was invented here by Professor Harald Zuhausen, and he got the Nobel Prize for that, or also a very advanced methodology in microscopy, nanoscopy with STAT microscopy was co-developed at DKFZ, and Stefan Hell got the Nobel Prize for that a couple of years back. We have invested a lot into infection and cancers and work, for example, not only on HPV, we also work against liver cancer, and of course hepatitis is a very prominent cause of liver cancer, and Ralf Bartenschlager got the Lasker Award for his work on anti-HCV treatment. But we also developed things like PSMA, which spread over the world. We work on genetic cancer classification, and most of the molecular classification in neuro-oncology and pediatric oncology came out of our research. And then there are other fields like stem cell in cancer and many more. So we are very wide in the research we do. And with that, I will come to the point what we do as an international strategy and how we see international strategy for our center and also for our partners. So cancer clearly is international. It's an international disease, and the worldwide cases of cancer are increasing from 20 million today to 30 million in 2040. And science, as we all also know, is also very international. We all cooperate with different scientists in different parts of the world. So we have cooperation programs, which I think is a more classical form of international cooperation. You find one individual scientist or a group of scientists, and you work in a very specific field without any contracts and so on a bilateral basis, because you want to work together with your partner scientists. But at DICA-FC, we also believe that that cannot be all. We also believe in institutional and twinning partnerships, which have a more strategic view and which also have a more formal framework. So what are the benefits of international strategy, and particularly of forming institutional or twinning partnerships? One benefit is that we raise synergies through global expertise, infrastructures, and materials. No center, even the very big centers, including ours, can do everything. So there's nobody in the world is in the position to do all cancer research. We need to put our grips together, and we have to work together to have enough expertise, to have enough infrastructures, and to have enough materials. Very clearly, we can assemble much larger cohorts, and that is necessary, among others, for increasing individualization of cancer treatments or cancer preventions. And then, and that has already pointed out by Professor Bates in his lecture just before mine, there are many differences between different countries, and they are in genetic differences, they are in lifestyle heterogeneities, they are in the health systems. So we need to consider these heterogeneities between different regions of the world if we really want to fight cancer as a global cause of death. And then we can also, by working together, we can raise synergies between research and governmental programs, which again bring profound impact for cancer research. To show you one example here on bilateral cooperation, this is a very simple graph showing where, if I look at the publications from our center, about 60% of our publications are with international co-authors. And most of those publications come out of bilateral or network-like cooperation models. And that's very good to have that. And without that, cancer research would be not in the position as cancer research is today. But speaking about the bilateral, more strategic and more contract binding partnerships, I show you the world map here, and you see that we have a number of these partnerships in most parts of the world, not in all. In Africa, we have two. We have one which exists for the last 5 years with the University of Namibia, and a very recent one, and therefore I'm so happy to be able to speak here today with the Pan-African Cancer Research Institute in Pretoria. So what do we do with such strategic partnerships? With the Namibian partnerships, we signed contracts with the University of Namibia and with the Ministry of Health and Social Services. So that's a trilateral contract we have here. And we concentrate in the moment on 3 key activities. One is to work together in cervical cancer screening program. which is a win-win situation, because for us, with a large track record in HPV research, we can connect our track record to real studies. And for the Namibian population, because the screening programs in the moment are far away, as we all know, from perfect in almost all parts of the world. Then we established a radiology training program here in Heidelberg for radiologists, both diagnostic and therapeutic from Namibia. And we established a joint tumor board, which again is a win-win situation, because it brings us very interesting information on cancer care, how it's done in Namibia. And we can sometimes help with some solutions which are helpful from our side. And with Pretoria, we have signed a memorandum of understanding just last year in February. And the key activities here will be different. They will be a collaboration through education and training, in particular for young research faculty and junior scientists which wish to exchange either from Heidelberg to Pretoria or vice versa. And we also point in these key activities to set up joint research projects. Unfortunately, because of the COVID pandemic, this all was delayed and is delayed, but I'm very optimistic and very much looking forward to setting up the joint programs and go together from here. And that was my very brief introduction on our view of collaborations. And I thank you very much for listening and look forward to questions later.
Thank you very much, Prof. And again, highlighting working together, and we want to say thank you for the collaboration that you are having with us here at PACRI, and also I think the work that you are doing across the region and globally as well in your capacity as the Director of DKFZ. Colleagues, then the next presenter is Dr. Louis Cantley, and he's the Dana-Farber or Harvard Center Cancer Center Director in Boston in USA. And the title of his presentation will be, "What will cancer treatment look like in 2040 in a major cancer center?" And I do have a few words to say about Professor Cantley, who received his BSc chemistry degree at Wesleyan College in West Virginia, and he completed his PhD in biophysical chemistry at Cornell University in New York, and he continued his postdoctoral education in Harvard from 1975 to 1978, and the biochemical basis for metabolic control by growth factors has been a central focus of his lab for over the last 25 years. Prof. Cantley has won numerous awards, including the ASBMB Avanti Award for Lipid Research, and recently he has won the Canada Gardner International Award in 2015, the Wolf Prize in Medicine in 2016, and the OncLive Giants of Cancer in 2017, the Louisa Gross Howes Prize in 2019, and most recently his latest award is the Paul Janssen Award in 2020. Thank you so much, Professor Louis Cantley, for being here with us. You're most welcome.
Well, thank you. It's a pleasure to be able to speak with you today. It's I wish I could be there present. I was in South Africa about 3 years ago. It was a fantastic opportunity to see the country. So I've been challenged with the task of speculating about what a cancer center will be like 20 years from today. And I should say that if we actually manage to implement what has been recommended by the 3 previous speakers, which I completely concur with, they've brought up all the ways that we can prevent cancer. Maybe we don't even need a cancer center in 20 years. But the truth is that even if we did implement all of these ways of preventing cancer, certain cancers will still occur, including particularly cancers where the patient is genetically predisposed to develop the cancer, like BRCA cancers. So we will need cancer centers in the future, but hopefully fewer of them and fewer cancer patients. I will add to an additional mechanism I think will be important for prevention that hasn't been brought up, and that is to reduce obesity, and in particular to reduce the sugar in the diet. If one goes back and looks at cancers in Europe, Western Europe, and the United States prior to 1900, cancers were quite rare. And it wasn't just because they weren't diagnosed, because people weren't dying of cancers. And at a much lower rate, they were dying of cancers. And of course, lung cancer was, we can explain, that was due to an increase in smoking. But even if you eliminate lung cancer, breast cancers and many other cancer rates went up dramatically after 1900. And what happened around that time is a pretty dramatic drop in the cost of sugar. So sugars became from exotic foods that were hard to get to very cheap, that everyone could add sugar to their coffee, add sugar to have desserts every day with lots of sugar added. And that, of course, ultimately correlated with obesity and a dramatic increase in cancer. Now, we've actually looked in some detail as to the molecular mechanism by which this increased consumption of sugar might explain this increase in cancer. In one case, in colorectal cancer, it turns out that a combination of glucose plus fructose, which is the mixture that you see in sucrose, will drive the growth of polyps in the colon in mouse models of colorectal cancer. So I'm pretty convinced that the pretty dramatic increase in colorectal cancer that we've seen in the United States can be explained by this increase in sugar consumption. But it turns out obesity has another effect on cancer, independent of the sugar directly driving the growth of tumors. And that is that with obesity, almost always comes insulin resistance. So insulin resistance means that your liver, fat, and muscle are not properly responding to insulin. So the pancreas has to make a lot more insulin in order to keep up with the demand to bring the glucose level back to normal. But we also know from work in my own laboratory that insulin activates the enzyme called PI3K, phosphatidylinositol 3 kinase, an enzyme that was discovered in my laboratory more than 25 years ago. And PI3K is the most frequently mutated gene in breast cancer, very frequently mutated in colorectal cancer, and a host of other cancers. And those mutations allow it to be activated by insulin much more dramatically. So this correlation between obesity and increased rates of cancer is probably mostly explained by the higher levels of insulin that obese patients have that's helping to drive a number of cancers. So I think that's one other way that we can help prevent cancers is reducing sugar consumption. And that can work in multiple ways. But I now want to focus on the question of, what's a cancer center going to be like 20 years from now? So assuming that even if we eliminate sugar from the diet and do all the other preventions that were suggested here today, there's still going to be people who come down with cancers for various reasons. And so how do we deal with the cancers? Now, before going 20 years in the future, it might help to go 20 years in the past and see what's changed in cancer therapy. Around 20 years ago, there were two new targeted drugs that were developed. One was Herceptin. This is an antibody that targets the HER2 gene product, and that was approved around 20 years ago for HER2 amplified breast cancer. It only gave about a 3 or 4 month life extension in the approval trial, but once it got introduced as an adjuvant therapy after surgery, at early stage when the disease was minimal, it turns out recurrence was dramatically reduced, something like 80% reduction in occurrence in that disease, which previously after surgery would come back 80 or 90% of the time. and at that stage was incurable. So this is a targeted therapy that's been a home run if used properly at the right stage of the disease. The second targeted therapy that came around about the same time is a drug called Gleevec that targeted the BCR-ABL gene fusion that occurs in chronic myelogenous leukemia. And that drug is quite safe, minimum toxicity, and dramatically controls the disease, but really never cures the disease. So people who go on Gleevec can keep their disease CML at check, but they have to take it essentially the rest of their lives. So again, clearly a home run in life extension, but not a cure. So, how can we actually get cures? And I would say that the technology that's really opened up possibilities of cure is immune therapy. And so we know of numerous checkpoint inhibitors that have now been approved that target proteins that are involved in keeping the immune system from being too activated so that you don't get autoimmune diseases. So we are protected from our immune system attacking our normal tissue. But those same checkpoints also eliminate or reduce the ability of the immune system to attack tumors. So the antibodies against these various checkpoints have gone in clinical trials, and multiple ones have now been approved. Anti-CTLA-4, nivolumab, et cetera, all of these are now approved and having a big impact. And in melanoma, we are now seeing cures. So previously, once one had metastatic melanoma, you could get life extension with targeted therapies, BRAF, for example, but no one was ever cured. But with these immune therapies, you can actually get cures. So I think, in fact, the only way we ever truly get rid of a cancer is if we engage the immune system to attack the cancer, because no chemotherapy and no targeted therapy is really able to eliminate every single cancer cell in your body. But once the immune system attacks it, you can continue to survey and get rid of all the cancer cells. So I think this is where the future is going to be. So asking now into the future, what's going to change? I think we're going to have many more types of immune therapies. We haven't begun to approach all the ways in which we can engage the immune system. Now, we've talked some about vaccines, and clearly vaccines can, by preventing viral infections that drive cancers, can reduce cancer risks. But can we get vaccines that actually are not targeting viruses, but targeting the tumor itself? And I think I'm very optimistic that that is going to be possible. Obviously, if you know what antigens are being neoantigens due to mutations are occurring in the cancer, and this can be done by sequencing the whole genome of it, or at least a whole exome of the cancer, you can figure out what the mutations are and generate a personalized vaccine for each individual patient. But that's very expensive. It turns out there's another approach that we're quite excited about and have been working on for several years now, as well as other laboratories. And that is the observation that tumors often present phosphopeptides as antigens. So these are not mutated proteins that are getting presented in the MHC complex, but rather phosphorylated peptides of normal proteins. And it turns out this is quite common in cancers, and it's also common in virally infected cells, that you turn up various protein kinase pathways that deal with the stress in the cell. They phosphorylate various proteins, and those proteins end up getting presented on the MHC complex to tell the immune system there's something going on in that cell. Now, this probably evolved for the purpose of surveying for virally infected cells and getting the immune system to attack the cell, not because it's presenting a viral antigen, but because it's presenting a phosphorylated normal protein in that cell long before you have a viral antigen immune response. And this allows the immune system to attack virally infected cells earlier. It turns out the exact same phosphopeptides that you see in virally infected cells also show up in cancer cells because they're under a similar kind of stress. And so the question then is, can we develop phosphopeptide antigens that will be globally useful in treating all cancers, independent of what the mutations are in the cancer or independent of whether it's the virally induced cancer. And so we're very excited about this and have been working to first understand what are the most common phospholipeptides you see. And then secondly, if we raise antibodies against those phospholipeptides or use the phospholipeptides themselves as into injections to boost the immune attack, is this going to be effective at treating cancers after they're already established, as opposed to preventing cancer? So these are vaccines as therapies rather than vaccines for prevention. So those are some of the technologies that my lab's currently working on, which I think over the next 10 or 20 years may have a big impact on the disease. But what I think will be the biggest impact on this disease over the next 20 years, and you'll see in a cancer, the top cancer centers in the world in 20 years from now, is detection and sequencing. So we already talked about full exome sequencing, revealing all the mutations that are occurring in cancer. I would argue that we should be doing RNA-seq, in other words, sequencing every single RNA species that's in the tumor. This is rarely done today. Certainly not an approved diagnosis that you can get reimbursed for in the United States. But in cancer centers like our own, at least at Weill Cornell, where I was previously, we do this pretty commonly. And remarkably, you see a lot more things to attack in the tumor from RNA-seq than you see from full exome sequencing, because you see fusions of genes and fusions of RNAs that don't ever appear in normal cells, generating fused proteins that also are potentially neoantigens that can be presented. So I think this should be, and certainly 20 years from now, will be standard practice. Every single patient will get RNA-seq on their tumors. The other technology that's extremely exciting is single-cell RNA-seq. In this case, you take a biopsy from a tumor and you sequence, I won't get into the technology in great detail, but you sequence by an approach that allows you to determine RNA in each cell type that's in the tumor. So not only do you get the RNA in the tumor cells themselves, but you get RNA from macrophages in the tumor, from T cells, from B cells, from every fibroblast, every cell type in the tumor. You get a profile of what's going on in that cell type with regard to state of activation. And this begins to tell you in great detail, first of all, how many of each of those cell types are present, and secondly, what kind of state are they in. And this is beginning to reveal a lot about macrophages. And we see that the macrophage is typically in the cell not attacking the tumor, but rather protecting the tumor from being attacked by the lymphocytes. Macrophages in tumors are typically similar to macrophages in tissues undergoing repair, tissue repair, injury repair. So they see the tumor as an injured tissue that needs to be healed through making more cells and protecting those cells from the immune system to keep the T cells out and allow the tumor cell to grow more rapidly. So this really raises completely new areas of therapy that have not really been thought about before, of attacking the macrophage and either altering the state of the macrophage so that it attacks the tumor rather than protecting the tumor. And this can be done by understanding the signaling pathways that macrophages use to switch from one state to another, or to try to kill the macrophage altogether with therapies. And so we're now beginning to learn enough about these macrophages that are supporting the tumor to begin to develop new therapies in that area. So I think 20 years from now, and hopefully even 5 years from now, there will be a number of new drugs approved that will attack macrophages in the tumor microenvironment. Fibroblasts as well, they're all, clearly the fibroblasts are often supporting the tumor. Are there ways to engage this? So we need to know in great detail, and I think this is where the biggest change will be in cancer centers. The top cancer centers will be doing all of these sequencing technologies. They get cheaper every year. And we will know so much more about the cancer than we do today, that the decision of how to treat it and how to actually engage the immune system to kill it is going to be much more scientific than what we're currently doing. So that's what I think we'll see in the future. Those are going to be the biggest changes. And I'm glad we'll take questions later.
Thank you very much, Dr. Louis Cantley. And I think what I really liked about your presentation is that although you were giving us a peek into the future for the colleagues who are listening, and also we have a number of emerging scholars who are in the audience, you're really also giving us a peek in terms of the research direction that we should be focusing on, looking at issues of lifestyle, immune therapy, possible tumor targeting vaccines, sequencing, and newer technologies in terms of drugs and sequencing technology as well. And so in essence, really, I want to thank you so much for that. And not only have you sketched for us what major cancer centers will be looking like in 2040, but really you've given us food for thought, particularly in terms of crafting a research agenda for cancer. And so, colleagues, then we gather this evening under the theme Transforming the Fight Against Cancer in Africa, from cancer control and prevention to novel therapeutics for improved health outcomes. And as all our speakers have been saying this evening, that we can't do it alone. We have to work with others. And so it gives me great pleasure now to turn the program to our industry and business partners who are in support of the advancement of the Pan-African Center for Research Institute. That's what PACRI stands for. And our first person then who's going to give a message of support really doesn't need a lot of introduction, and that is Dr. Patrice Motsepe, who is the president of the Confederation of African Football. And for those of you who did not watch the CAF tournament, it was really a wonderful and spectacular event. Dr. Motsepe is also the executive chairman of African Rainbow, and he obtained his LLB and doctorate of commerce, an honorary doctorate at the University of Witwatersrand. He's also got a number of honorary degrees, a doctor in management and commerce from the University of Fort Hare, a BA Law and Doctor of Law from the University of Eswatini, which you would know was formerly called the University of Swaziland. And in 1994, he founded what he called Future Mining, which grew rapidly to become quite a successful company. And he's also a recipient of the Achiever Award from Harvard University. And he also, together with his wife, Dr. Precious Moloi Motsepe, joined the Giving Pledge, which was started by Warren Buffett and Bill and Melinda Gates. And on the 28th of March, we were grateful as a health system for the pledge that Dr. Motsepe gave of $1 billion to assist South Africa and Africa's response to the challenges presented by COVID-19 pandemic. Over to you, Dr. Motsepe. So perhaps while we wait for Dr. Motsepe, we will continue then to Dr. Sandeep Bobby Reddy. And Dr. Reddy he joined the Immunity Bio in August 2020 as his Chief Medical Officer. And his responsibilities include overseeing the clinical department, the clinical operations, biostatistics, and medical affairs. And previously, he served as a Chief Medical Officer at NunHealth since 2017. And he oversaw the education, outreach, clinical development programs there. Dr. Reddy was the Chief of Staff at Los Amiltos Medical Center, and he is actively practicing clinical hematology and oncology. Thank you so much, Dr. Reddy, over to you.
Thank you. Thank you very much. I want to thank the organizers for the invitation, and I'm very excited to be able to present. I'm sorry I could not be there with you. I'm going to share my screen and make sure this is working. Okay, hopefully you can all see my slides now. So I'll just is that full screen now, I hope. Okay, should be full screen now. Okay, so basically a little bit of background about the company. So here you see President Ramaphosa and our founder and chairman, Patrick Soon-Shiong, about a month ago, announcing this collaboration. So Patrick is originally from South Africa, is born in Cape Town, and he's wanted for a long time to be able to give back. He developed a drug in the United States called Abraxane, a cancer therapeutic, and has been a pioneer in the pharmaceutical industry. One of the things that has motivated him is to be able to bring technology to the rest of the world and really advance the ability to develop pharmaceuticals and cell-based products outside of just the US. And so one of these, as part of this coalition, is our investment in South Africa. So this is the NANT South Africa plant in Brackengate, where we are ramping up to begin production of COVID vaccines, but also other therapeutics as well. And the idea is to establish a presence in the continent and build capabilities in South Africa, in the African region, to reduce dependence on external companies and countries, really. Now, as part of this, one of the first things that we did is a few years ago, we were in a partnership to start sequencing the COVID variants that are being seen. And as part of that, we sent over some sequencing instruments, NovaSeq that you see here. And we have a long experience actually in the sequencing arena. And I wanted to talk to you about that today and about the potential of collaboration with some of the investigators there. So this is just a little bit of the history and background of where we've been on the sequencing side. But towards the right, you see that we actually have created a tumor normal sequencing platform that has gone through FDA clearance. And what we did really was to build this around, I think some of the things that Dr. Cantley just spoke about, is being able to evaluate for variants that aren't just the standard variants that you would treat with, say, a targeted therapy. But the idea is that these variants are, in fact, associated with a neoantigen, a neoepitope, and those could be then targeted with perhaps a vaccine or some type of immunotherapy. So specifically, we had presented this data at ASCO, I think in 2019, and actually getting right to the heart of what Dr. Cantley mentioned, which is DNA alone may not actually be enough. And so we have to think about actually doing RNA sequencing, which is very important because we have shown now that there's evidence of selective silencing of these neoepitopes to avoid immune surveillance. And so both DNA sequencing and RNA sequencing really are going to be necessary. And of course, we strongly believe that immunotherapy is important to achieve long-term disease control. A lot of progress has been made, obviously, with targeted therapies and chemotherapies to date. But many of those patients, if not caught early, will ultimately succumb to their disease. But immunotherapy has the promise of actually leading to long-term cure. Now, in the center, this is just the highlight of the company what we're doing now. But these are the 4 platforms that we have currently. And it's very important, actually, the one on the far right here, the natural killer cells. What we've done is created an off-the-shelf natural killer cell platform. What that means is it's basically a blood transfusion. And one of the visions that Patrick had initially was this cannot be a CAR T therapy. It can't be something that can only be done in a very, very specialized center. The idea was that it can be done anywhere. In the most remote clinic where you can do a blood transfusion, you should be able to do a cell product. And I'll walk you through how we've been able to achieve that. The first thing that we've done is taken this molecule forward, which is a drug we call N803 or Activa. It's an interleukin-15-like compound, but it has some special properties separating it from interleukin-15. The first is that it has a mutation in the cytokine portion that enhances its binding affinity to the target receptor. The second is that it is fused with an FC backbone, so it has a significantly longer half-life. And then the third thing is that there's an IL-15 receptor alpha construct that presents the cytokine to the receptors in such a manner that it has highly specific interaction with the beta gamma complex on T cells rather than the alpha receptors. Why is this important? You see in the middle of this slide, you can see it's because you see stimulation of the immune effectors, which are NK cells and CD8 positive T cells, but you don't see increase in Tregs. And so unlike many of the cytokine drugs that are either in the clinic today, for example, interferon or interleukin, which have significant side effects because of the non-specificity of their action, this is a very clean molecule. There's very specific action. And so we're getting that immune potentiation that we've been looking for, activation of the killing cells, but without the side effects of non-specific activation. So very, very clean. And I think that's important because that allows us now to adjunct other immune approaches. Because if we can stimulate T cells, well, that means we can stimulate maybe the CAR T to perform more effectively. If we can stimulate NK cells, we can target the tumors that are escaping through that immune surveillance and immune escape mechanism. Because unfortunately, as effective as the checkpoint inhibitors have been, one of the things that we've learned is that the tumors also learn. They are smart, they evolve. And one of the key mechanisms of immune escape is through loss of MHC. And so once the cell has disguised itself, once it's lost MHC, any modulation to a T cell is no longer going to be effective. It's going to take some other mechanism. And that's where the NK cell, from an immune approach, is very attractive. We might be able to do this with chemotherapy and radiation, but with the NK cell, we think it's potentially more effective and longer lasting. The first clinical evidence of this is with the N803 in combination with BCG. It's a drug I think everyone is familiar with, but in the context of bladder cancer. And so this was just presented less than a week ago at the ASCO GU meeting. And what was seen is that historically, in the right, in this paper, this review article, they have stated that what would be meaningful would be a 25% effect at 18 months. And what we are seeing, in fact, is much higher. We're seeing 34% at 18 months and in the carcinoma in situ group, and 53% in the papillary group. So much higher than what was even thought possible. In fact, in the bottom on the right, on the left, you can see they said, the authors concluded, we are in partial agreement with these recommendations, but we feel that 30% response at 18 months is likely too high and may not be realistically achievable. Well, the good news is it is achievable. And so I think the point is, with effective immunotherapy, going back to what some of the other discussants have said today, with effective immunotherapy, not only can we achieve response, but we can actually get durability of that response. And what's nice is that the patients, they don't have to keep on taking a medication which may have a toxic side effect. Because you're training the immune system and you're creating a trained immune memory, we now can have long duration of activity. Now, the exciting thing is to take that into an area where immunotherapy does not work. So this is actually, we presented this in January of this year. at the ASCO GI meeting. And this is in pancreatic cancer, where historically no immunotherapy has shown any benefit whatsoever. And for example, checkpoint inhibitors or even a cell-based immunotherapeutic approach. Here, what we've done is we've actually combined different aspects from that first slide I showed you where we had different technologies. We've combined them together to create what we call the NAN cancer vaccine. What that involves is low-dose chemotherapy and radiation. And what that does is it exposes the tumor microenvironment to the immune system. So we are creating a damp response, the damage-associated molecular pattern. And that, we're not trying to actually, I think it's very important that people understand, we're not trying to kill the cancer with that radiation or chemotherapy. We're not leading to cytotoxicity directly. What we want to achieve, in fact, is damage. When the cells become damaged, when they become stressed, they start to undergo changes that allow for exposure to the immune system. Number one, there's antigen cascade, antigen release, which would expose the tumor cell now to an immune attack. So we basically prime, and I think we've now become familiar with prime and boost with COVID. So we prime the tumor microenvironment, and then we boost now with the immune attack. And the immune attack here is with the N803 that I just discussed, which activates the NK cells. But we also give off-the-shelf NK cells. So these are produced in one of our factories as an allogeneic product. And these NK cells have a CAR moiety targeted against PD-L1. So they will go and attack the PD-L1 positive cells and eliminate them. And we believe this eliminates the suppressors. So we want to activate the activators and eliminate the suppressors. And historically, of course, as I mentioned, pancreatic cancer is a very poor target for immunotherapy with literally no efficacy seen. But now we are seeing a doubling in the center box here, doubling of the median overall survival in late-line pancreatic cancer compared to historical average. And we believe that's because of this combined immunotherapeutic approach that is necessary. What's really important is that these cells, we can basically treat like a blood transfusion or a unit of platelets. Now, they don't come in a bag, they come in a glass vial, but they are produced and then frozen and then shipped to the site where they're warmed over 30 minutes and then just hung at the bedside and given. There's no significant toxicity. There's no cytokine release. This does not require hospitalization. The entire trial was done as an outpatient. And in the United States, it was done in California, but also in Sioux Falls, South Dakota. So, that's relatively remote. And we chose that for a reason. One of the things we wanted to do is to proof of concept. We can do this anywhere. So we're very excited about the possibility of this being a trial that we would then bring to the African continent and be able to do here as one of the first cell-based wholly outpatient therapies in the continent. Now, one of the first trial that we're actually wanting to do very soon, very quickly with PACRI, and we've had some preliminary conversations with Professor Zodwa, we're very excited about this, is aldoxorubicin, which is a different formulation of doxorubicin. So doxorubicin is I think for those in the field, is a very familiar chemotherapy. It's been around for 60, 70 years. What we've done is we've taken doxorubicin and we have conjugated it to this pH-sensitive hydrazine linker with an albumin binding site. So when it enters circulation, albumin is bound to it, and therefore it is not being released directly into the other organs, particularly the heart, because unfortunately doxorubicin is very cardiac toxic. But this drug is not. It's not released into the cardiac myocytes. And we've been able to give 5 and 6 times the cumulative dose of aldoxorubicin compared to doxorubicin to patients without any evidence of cardiac dysfunction. So what it does is it's released in the tumor microenvironment where the pH is a little bit lower and then concentrates around the tumor. Now, one of the things that we're very excited about is the treatment of HIV-associated Kaposi sarcoma. So this was an early study that was done a few years ago in the United States in collaboration with a group at LSU in Louisiana. And what they showed was very high uptake of the drug directly into the tumor. They did, here you can see in the center here, they did skin biopsies and they were able to show there was good concentration of the drug locally. So it wasn't being systemically, into other tissues. And importantly, there was a very good response rate of 67% in the initial treatment. So doxorubicin or liposomal doxorubicin is one of the standards of care for this disease. This now becomes another option for people who may otherwise have toxicity, who may exceed their lifetime threshold. And we're very excited to open this trial in Africa with you. So I just wanted to say thank you, and we look forward to our collaborations with PACRI and the rest of you, both on the clinical trial side for these therapeutics, but also on the genomic side, transcriptomic side, where we can partner with you on perhaps the bioinformatics. And I will stop there. And again, I thank you very much for the opportunity.
Thank you very much, Dr. Reddy. And as I said, Dr. Reddy is the Chief Medical Officer at Immunity Bio Inc. in LA. And it's always such a joy to hear, Dr. Reddy, about the cutting edge research that you have, particularly the work that will be done in the Africa region. Our next industry and business support message, colleagues, comes from Bert de Boer, who is a Senior Manager, Oncology and Infectious Diseases and Emerging Markets in Illumina Inc. in San Diego, California, USA. And Bert has extensive history in clinical pathology space after working for 20 years in hospitals, 12 of which were in the role of the pathology department as a pathology department head. And then he left after that. And since then, he's worked in various international and commercial roles, applying his expertise to senior marketing, sales, corporate liaison, and business development roles. Additionally, he owned his own company for 7 years, and he has consulted for several global corporates. But thank you so much for being with us. Over to you.
Thank you very much for the organization, for inviting me. Professor Damini, really nice to be here. We met each other at ESMO and you made myself enthusiastic, and my colleagues told me that I needed to come back after, 2 weeks from the Netherlands, flying into South Africa. So before I start with my presentation, it was very difficult to start and to find a subject because there are so many nice subjects to talk about. And I think because I've worked for so many years in pathology, a part of my body is fixed by formalin. So I'm still very into pathology. And so I thought I'm not going to give you only a pitch for our company, but I want to stay close to my heart and where we use our technologies for. If I look back at the presentations from the different professors, I heard a lot of good information that we are also sharing. But what I would add to it, I think in the near future, what is very important is that we don't forget to look at the microbiome and the resistance for cancer treatments. I think microbiome and also the metatranscriptome will be very important to save lives. Having said that, I'm going to go to my presentation, because otherwise I start to talk about HPV, because that's one of my other hobbies. So what I've done, I would like to take you on a patient journey. So as we look at it, first of all, if cancer starts in our genes, it's still a question, why aren't we using genomics more often? in routinely oncology patients. In today's environment, we see patients coming in with late symptoms, blood at stool, a long cough, all kinds of beta symptoms, and they come into your office and they're critical ill. But let's take one patient. Let's take a colorectal patient. So in this case, most likely you're going to refer them to a coloscopy to look at it. And if a doctor is looking at the coloscopy, he will see, in this case, a mass, where we know that it's probably malignant, because even the most experienced people that do the scopies will see that. But you're never going to rule that out, because you need to have your histopathology to give that diagnosis. And it's not rocket science. If you look here in the second part of my presentation, the second picture, it's not a really difficult diagnosis. That's an adenocarcinoma. And that's what the pathologist will see under a microscope. But very important here is that what you see under your microscope, as a pathologist, the patient will not die from that. The patient will die from something that is still in the body. So it's what we always said, what Virchow already did in the early days, with his H&E slides. He could tell it's a cancer, but we cannot tell too much about the behavior. Over the years, we started to look at immunohistochemistry. We did a lot of FISH, we did a lot of tests, but still you want to know exactly what's going on. So the next step will be that such a patient, you go to a CT scan, maybe an MRI, you describe that. No metastasis seen there. So that's good. So then we're going to we hospitalize the patient, there's an operation, we do a partially colorectal resection, send it to the pathologist. We're going to look at it. Of course, the slides will tell us exactly the same as the biopsies, but we need to do it to go to the TNM and tell something about the tumor. So you will see the tumor, you will tell everything, you talk about the cutting edges from the surgeon if they are free, everything is okay. But then we go to the lymph nodes, because in the CT scans, they didn't see a metastasis, but they didn't see the M of the TNM. They didn't see the tumor in a distance. But what they didn't see was that in the lymph nodes, they found tumor cells. So multiple tumor cells in the lymph nodes. What means that you need to go back to this surgeon, this oncology surgeon or oncologist, and tell them, listen, I found it adenocarcinoma, what we know, and we found 7 of the 14 lymph nodes positive. What happens then is that we go to molecular technologies. Most of the time we will do some RAS typing, we will do some MSI, we look probably at TMB, so we're going to do a lot of tests. But still this patient needs to be treated. So what will happen is that based on the outcome, and also based on the histopathology, you're going to treat that patient. Most of the times with these diagnoses, you will go to a chemotherapy. And patients will be screened often with CEA to see if there's recurrence or if there's something going on. You will do some CT scans during a period of time. But you don't know exactly if that tumor comes back. That's in a later stage that you can see that. So patients in this paradigm are typically diagnosed with a stage 4, 3 or 4 cancer and have a poor long-term outcome, especially diagnosed in stage 5. So now this is an example of a colorectal cancer where in multiple countries they are screening for colorectal cancer. What about those patients where we are not screening for? These are in a complete other picture. Then we go to the next step. I try to keep me on my 10 minutes because it was asked for. So now we are at the doorstep to the time that in the very near future where genomics has enabled an entire new approach, right? So we have another patient. We have the same colorectal cancer, but it's another patient. So you get them much earlier into your practice because you're screened probably on a liquid biopsy. So you get some information, and already at that time, you can see much more than we have seen in the past. So what you will do then is you will send again this patient to your colonoscopist. He looks at it, biopsies. It's a cancer. Now we can do two things. And in the future, you will see that some of the doctors will choose for a resection, or they say, no, I want to treat this patient with new therapies with the tumor on board. It depends on the surgical surrounding that you have to operate. So having said this and the diagnosis there, you get your specimen in the pathology department. Again, you're going to look at the tumor. You're going to measure the tumor. You're going to look at the lymph nodes. In this case, the lymph nodes are negative. What does that mean? It's a stage 2, a localized tumor from the colon. Now the patient can avoid adjuvant therapy, assuming all results from a follow-up CGP test indicates no findings suggesting benefit from target or IO therapy. And now this is where things get interesting with these new technologies, because there remains a residual risk of disease recurrence. Imagine now that we can personalize a monitoring plan for the patient. The lab is able to perform single-cell analysis, we heard it before, single-cell analysis to tailor an assay specific to that patient's variants. When the disease recurs, it will be detected in an early stage. And comprehensive genomic profiling, and CGP, as we call it, TSF500, as we call it at Illumina, with 523 genes, is typical, really, a comprehensive genomic profiling. It's not 50 genes. So, and will occur with liquid biopsy tests, assuming identification of specific target markers or markers predicting response to IO therapy. The treatment will likely result in a long-term free disease status. Further to this, what we will see is that these patients get more drug. So they have not only their cancer drug, they have other drug. So these patients will also likely require pain management and other types of treatment, where we can help with pharmacogenetic profiling. This is going to change the world for them. In these future states where patients are actively screened with liquid biopsies, and diagnoses are made much more earlier than in the past, these patients will have a much better prognosis. And an associated long-term survival is very good. As I told you, I wanted to talk about much more than only this patient journey. So I wanted to talk about microbiome. I wanted to talk about transcriptomes. What we see now, if you look at this picture, there were a lot of non-NGS tests used in the lab. And also in my lab, we used FISH, we used DISH. We had all kinds of immunohistochemistry tests. But you see that in that time, people went to small panels. And these small panels could help you with the actionables. But the doctors wanted to have more, because sometimes you found something and then a patient didn't respond. So you need to see more. And you want to compare these patients that do not respond on therapies. So we go to the larger panels, like the TSF500s, the TSF500 ctDNA, so you get solid and ctDNA, you can look at multiple genes. The next step will be, you're going to make choices. Are we going to exomes? Are we going to transcriptomes? Are we going to whole genome sequencing? Before I close my presentation, I can tell you that currently in the Netherlands, we have a new project on cup tumors. So those are the patients where you find a tumor, but the primary tumor is not diagnosed. So in this case, we are now doing or whole genome sequencing or a TSF500 assay, and that's also reimbursed. So we try to get more and more details on patients with different kinds of tumors. I have 3 children. My second child is very keen on what his dad is doing. So when he was 10 years old, he wanted to present HPV at school. Can you imagine what happened? I was in the MR, so I was working close together with the director, so I came in a meeting, and he said, I'm not sure if this is normal that a child of 10 years start to talk about HPV, but he had seen me in the papers, and so he wanted to do that. Before I flew to South Africa, he asked me, when do you come back? I said, well, around the weekend. Okay. He said, Dad, may I ask you a question? He's 16 years old now. He said, what does wake you up at night? I said, good one. About your work, he said. I said, okay. I said, yeah, patient dying from cancer. He said, oh, okay, yeah. Like your mother, who died last September on colorectal cancer. I said, yes, because he knows a little bit about what I'm doing. He looks in my books and read the papers. I said, yes. He said, what's waking you up more? What is your dream? I said, my dream would be if we could do whole genome sequencing on PKU blood. And I'm not sure if you know that we do the PKUs. If a baby is born, in the first 5 days you take some blood and you have the dry blood spots and you look at some aberrations. I said, if we could do that, we could save lives. Because in some cases, with inborn errors of the metabolism, you will see that with a treatment with a vitamin, this patient or this little baby will not be mentally retardated, but will grow up because he was missing just a small part. I said, if we could do that and we could screen on cancer, we're going to change the world. And I agree. With cancer centers like here, what you're building now, you're going to change the world. I have visited with Brigitte, I visited a few oncologists and pathologists in your country. And I'm impressed about the knowledge, but also the drive. And I hope that the Minister of Health is listening, but that if we work together with governments, with cancer centers, with companies like our diagnostic company, but also with pharma, we can help the world a lot. But we need to give the people the tools to work with it and be open to work together. Thank you so much.
Thank you so much, Bert, for taking us on two journeys, one on the whole genomic sequencing and the one on the patient. And I think your story at the end really illustrates that you're never too young, in fact, to be exposed to science. And it's just such a beautiful and heartwarming story. And I think one of the things then that you are charging us to say is that as much as we are opening these cancer centers, and as much as we are talking amongst ourselves as scientists, there is a need to extend a hand to younger people and to expose them to these newer technologies. So thank you so much for such a beautiful ending to your presentation and that heartwarming story. So colleagues will now turn over to Dr. Nhlanhla Msomi, who is the chairperson of Africa Bio, Next Biosciences here at home in South Africa. And Dr. Msomi holds a BSc in molecular genetics in biotechnology from Sussex University and a PhD in genetic engineering from the former University of Natal, which all of you would know is in Durban. And later he obtained a diploma in management, accounting and finance from Vaster College, as well as the International Executive Development Program at the Wits Business School. He's also completed a postgraduate diploma in strategy and innovation at the University of Oxford, which is in the UK. And during his academic career, he was the recipient of the National FRD, which is the Professor Chanel Award for Biotechnology. Nowadays, he also provides advisory and analytical services to government through Africa Bio on innovation and manufacturing value chain for vaccines. Over to you, Dr. Msomi.
Good evening, everybody. This is a classical case of the poor cousins being invited to say the last word, just so that the family feels represented. Thank you so much for the invitation. And I think what I want to do is to bound my presentation on two insights. One is as an Africa Bio representative. Maybe just by way of introduction, Africa Bio is a Pan-African Biotechnology Industry Association. It spans the whole gamut from university researchers to innovators to startups, all the way to big multinationals, big pharma, in the case of what we're here about. As Africa Bio, we recognize the importance of building the ecosystems. And I think it's often easy to forget that biotechnology is not that old as a contributor to economic development, whether you're thinking of biotechnology in its current format in the pharmaceutical industry. So today, I want to remind us of the old problem of industry-university linkages, because as people who represent business, the business of biotechnology, it's something that we often grapple with. How do we ensure that this relationship bears the fruit of what science ought to do? Science should not just be for the generation of knowledge for its own sake, particularly in a developing world context. And maybe the discourse should be centered around what Clayton Christensen, I think, aptly calls the jobs to be done challenge. What jobs need to be done? For research institutions such as PACRI, the objectives are clearly set out in their foundation statement to transform the fight against cancer in this continent, in Africa, for cancer control and prevention, for novel therapeutics and diagnostics. How do you do that? Because as a research institution, you are not going to be delivering that. It has to be delivered through industry. And Africa Bio, as one of the industry associations, is probably a conduit to that. But often we find that we have this gap or this distance between those who do research, who generate new knowledge, and those who actually manage to convert that research into usable products. Often we call it products. We could take a view that it's solutions. And I just want to raise an interesting concept, which I'm hoping that PACRI would look at. This is how to do innovation on a product or architectural innovation format. In other words, we talk about problems, about Africa being, having this challenge of cancer, and I think it was Professor from Nottingham earlier who showed the distribution of the cancers around the world, clearly articulating something that we've always argued as the industry or as the innovators that are based in Africa, that simply to import and to transfer the models that are in the north, in the global north, to try and solve our problems will leave us nowhere. And I'm not talking just about the products themselves, but even the paradigms that drive our science, the way we do science, the way we look at how problem solving ought to happen. The Vice Chancellor, when he opened today's proceedings, he did indicate the need for multidisciplinarity. And it always bothers me that a university such as University of Pretoria, as big as it is, as diverse as it is, there is no, at least visible strategy that looks at interdisciplinary thrust in solving problems of society. Often, obviously, these problems are solved through a market mechanism. But I am yet to see universities in this continent saying that let's think about new paradigms, let's think about new types of partnerships. Biotechnology certainly progresses or transitions through one of our most important stakeholders in Africa Bio, which is startups and smaller companies, smaller biotechs. And the second part of my presentation is really about the company that I work for or that I represent, and I suppose that buys me the ticket to be in Africa Bio, Next Biosciences. And Next Biosciences is a company that's been around for 14 years. It was founded on the notion of banking cord blood for stem cell banking. This was 14 years ago. This was the flavor of the day. It was the flavor of the day. And I can tell you now that 14 years later, that notion of banking your stem cells for future, your children's stem cells, has now been displaced by more advances in science. And yet we sit as a company, a very successful commercial company in this country, in this continent, with that model, with that paradigm, simply because we are not close to a university. We're not close to a PACRI. And PACRI does not, or universities do not make efforts to reach out, not to the big guys, because often when we talk about business, we mean big business. We do not mean the guys that really matter in biotechnology, which are people who are in the startup space, in the innovation space, highly innovative companies. And I think this is the message that we want to leave to PACRI, to say that the thinking, the models of doing business for research institutions, particularly in a developing country context, having seen the evidence that was shown on the distribution of the cancers in the world, means that often, as we see now with HIV, HIV is 40 years old, probably turning 50 years in 10 years. COVID is 2 years old. How many vaccines have you got? HIV has not a single vaccine. That's an indictment on the science and on the way science is conducted. And I hope PACRI does not fall into that. Thank you.
Dr. Msomi, that's why we put you close to the end. Because honestly, you have definitely said to us we need to borrow our VC's word, reimagine the collaborative space. And you are telling us we need to reimagine how we are collaborating, look at the startups and the innovation, and not forget that we have people here at home who are doing excellent work. And thank you for also highlighting the gaps and the inequities that are there between the researcher and the end user. So thank you very much for that powerful, powerful message. Next then message of support is coming from Mr. Botana Mboniswa, who is the director of Inqaba Biotechnical Industry. And for our colleagues from overseas, you let me know after, and then I will teach you how to say Inqaba, which is one of our cliques here at home. And Inqaba is a private genomics company. It's based here in Tshwane in Pretoria, and it employs over 100 people in a number of countries: South Africa, Kenya, Nigeria, Zimbabwe, Senegal, Mali, Tanzania, Ghana, and Uganda. And Inqaba Biotech offers sequencing services using state-of-the-art sequencing facilities. And Botana holds an MSc in biochemistry and an LLB degree. Over to you, Botana.
Thank you very much. I hope I'll be brief. Dr. Msomi said he's speaking, maybe he's a poor cousin. Maybe I'm speaking because we are part sponsors of the launch. It could very well be. But on a serious note, thank you very much, Dr. Dlamini, for inviting us to participate in this very important occasion. This is the 20th anniversary of our company. So we've been around for a little while. When NGS was not that famous and common, we started to invest in it at Inqaba Biotech. And importantly, we started to invest in it through the assistance of the South African government. At that time, there were innovation centers which were investing in different regions. And Inqaba, through partnership with one of the centers which were here, they started to acquire necessary equipment to assist in the advanced NGS work over a while. So 20 years is not that long, but I guess we've been around for some time. And that's just my introduction. I'm the director at Inqaba Biotech. I thought I'll just put the issue of PACBio as one of the products that we use and sell, but more importantly, how we were able to use that platform in the work that was being done in South Africa around COVID. So this is not so much important for cancer, but except to say that we've been quite helpful in supporting the COVID work in South Africa. These are some of the members of our team at different regions, different places in the continent. The point here is that as a company, we have a reach. Part of the discussions we're having with Dr. Dlamini is that over the last 20 years as a company, we have access to spaces in the continent which other companies will battle to build. Therefore, our intention is to continue to work together and use those relationships that we as a company have for the benefit of our company and the benefit of PACRI and the continent. I will not go too much into the history of the company because that was not my intention, except, well, some of the equipment that we have acquired over time, but that's not important as well. The important slide was this one, because that was my message of support to say how is it that we as a company are intending to assist and work with PACRI. The Vice Chancellor did mention that towards the end of this year, there's intention to open a facility for PACRI. What we have committed to Dr. Dlamini is that before that even happens, we as a company are prepared to work with PACRI and make our facilities available, and also, if necessary, expose the physicians to the technology of the NGS and others. So we are ready and committed to assist PACRI in its vision. Also, we are prepared to assist and work with PACRI in the fundraising initiatives, because that's going to be very important. This is a very expensive initiative. I'm sure the university will carry most of it, but it is not advisable. We must all work together to make this vision realizable. And we have committed ourselves there where we are able to assist and work with you in making sure that we make this vision a reality. We should do that. Where there is a need and we can assist on matters of clinical trials and so forth, even if we don't do it, through the network that we have and the reach within the continent, we have committed that we will assist in that regard. So that it's in brief the message of support that I bring from our company, that we believe in this vision of PACRI. We are based here in Pretoria, our headquarters. We want to work as closely as possible with your team, Dr. Zodwa, and the university, and make sure that we do not fail, because this vision is too big for it to fail. Thank you very much.
Thank you very much, Mr. Mboniswa, and we are so excited, of course, I can tell you, in terms of partnering with Ingaba Biotechnology, particularly that it's here right on our doorstep. And I think on behalf of Professor Zodo, I commit us to working there, and on behalf of, in my capacity as also holding the cap for our Dean, Prof. Diakha, I think I can say we are excited in terms of not only just partnering with you, but just ensuring that our training platform is expanded to working with partners like yourself. And now, ladies and gentlemen and colleagues, we turn it over to a message that will be delivered by Sandhya Singh. And this message is from our Minister, Dr. Joe Patler. And since we have an international audience, and although our Honorable Minister was not able to join us and has though sent his message, I will just read his bio a little bit. Dr. Patler was appointed as a Minister of Health on the 5th of August in 2021. Before that, he was our Deputy Minister, and he holds a Bachelor of Medicine and Bachelor of Surgery from the University of KwaZulu-Natal, and that is in Durban. And he's worked in a number of hospitals here at home. And before the unbanning of the ANC in 1990, he served in leadership positions in various mass democratic movement structures, including in the NEC of the United Democratic Front. And what is maybe not known as a tidbit is that our minister actually was involved in organizing the 2010 FIFA World Cup. And so thank you so much, Sandhya, for delivering the message on behalf of the minister. Over to you.
Good evening, Chair, and good evening to the colleagues. I bring you warm greetings on behalf of the Honourable Minister of Health. He deeply regrets not being able to be here. However, I have the pleasure of reading a message on his behalf. Just as context, I am from the National Department of Health, working in the cluster for non-communicable diseases. Thank you. The Vice Chancellor of the University of Pretoria, Professor Kupe, members of the organizing committee led by Professor Dlamini, distinguished ladies and gentlemen. It is indeed a privilege to interact with you at this esteemed gathering to launch a unique institute. This institute is aimed at upscaling our quest for knowledge and evidence to promote prevention, early detection, treatment, and ultimately to defeat those cancers which can be defeated. For decades, the scourge of cancer has been a threat to human life and remains as such today. Governments working with multilateral organizations like the UN and the WHO, as well as national stakeholders, including academia, research organizations, civil society, and the private sector, have engaged on alleviating unnecessary pain, suffering, and stigma associated with cancer. In South Africa, the challenges in the field of cancer prevention and control have a history. In the main, the history of unequal access to health services and the cost of treatment remains the thorny issue that the public sector has been striving to transform to ensure equity and access. Cancer services, like many other services in South Africa, are inequitably distributed. We know that service delivery is mainly concentrated in a few provinces, including the Western Cape, KwaZulu-Natal, and Gauteng. Other provinces have limited or no access to diagnostic, curative, rehabilitative, or palliative care services. In addition, there is documented lack of awareness among both the general public and healthcare professionals of cancer, which impacts negatively on the number of people being diagnosed and those referred for appropriate services. This situation is further enactment of the National Health Insurance Bill by Parliament will provide sustainable mechanism to ensure that all our people have access to a deserved health service, including affordable cancer treatment services. This milestone in our journey to leave no one behind demands partnerships, which many of you have mentioned already, built on trust, transparency, and common understanding of access and equity, which is entrenched in our human rights. At present, the curative services for people diagnosed with cancer are mainly situated in academic settings and consist of all the main key components of medical oncology, clinical hematology, radiation oncology, pediatric oncology, and specialized surgical services, including a multidisciplinary team. Infrastructure and capacity to treat adults with cancer are variable throughout the country, and this situation, unfortunately, was further exacerbated during the COVID pandemic as services continue to be interrupted and patients continue to be afraid to seek healthcare under these circumstances. Many tertiary specialist units are grossly understaffed. The ratios are not adequate, with limitations observed across the provinces, including the crisis presently experienced in Gauteng, which is a significant point of referral, not only from other provinces, but from across country borders. This adversely affects treatment outcomes, survival rates, and quality of survival. Emphasis of treatment and cure in these centers cannot occur at the exclusion of strengthening supporting health system and the continuum of care, especially in the community. Government has and needs to continue to intervene from different perspectives, including legislation, governance, as well as to promote best practice in service delivery. We've embarked on numerous efforts to curb smoking, with the introduction of Tobacco Products Control Act and the Tobacco Products Control Amendment Act, taxation of sugar-sweetened beverages, and enactment of the National Liquor Act, number 59 of 2003, as well as regulatory measures linked to diet and nutrition, which is linked to our country's massive burden of overweight and obesity, mentioned very clearly in one of the presentations. All of these risk factors contribute to preventable causes of cancer. In 2011, there was an introduction of regulation on the compulsory registration, that is the notification of cancer. And this led to accelerated reporting of patients to the National Cancer Registry, which lay dormant for many years since 1999. We are also in the process of finalizing the establishment of the Ekurhuleni population-based registry, and a similar registry is under consideration in KwaZulu-Natal at the moment. What is considered best practice in the country is the population-based school-based vaccination campaign, which was introduced in 2014, which offered the HPV vaccine to grade 5 girls twice a year to help reduce the risk of cervical cancer in future. And this was extremely significant because of the prevalence of HIV in our country. Since then, over 450,000 learners have been vaccinated annually in February and March, as well as September, October, to offer full protection to sexually naive girls aged 9 to 12 years with the Severix bivalent vaccine. While the National Cancer Strategic Plan, policies on breast cancer, cervical cancer, and the National Policy Framework and Strategy on Palliative Care were approved and are being implemented, guidelines on lung cancer are in an advanced stage of approval, and guidelines on prostate and childhood cancer are presently in development. In terms of governance, the Ministerial Advisory Committee on the Prevention and Control of Cancer was introduced, and first commenced activities in 2013 to advise the minister on all matters related to cancer. This resulted in increased engagement with various stakeholders in the cancer arena, including civil society, patient organizations, research bodies like yourself, academic institutions, and the private sector, collectively to promote the cancer agenda in the country. Currently, we are in the process of appointing a new advisory committee, which will be considered by the minister, and approval will take place shortly. Considering the principle of equitable access to care, it is important to create new services as well as to expand and sustain existing services to strengthen prevention and control as resources become available. Hence, critical review of existing problems in current service delivery needs to be addressed urgently to ensure service at a local level and to provide local solutions and efficacy of care in both public and private sectors. Regarding infrastructure development, which remains a huge problem, a multi-million oncology grant was created to accelerate the establishment of new services, as well as strengthen existing services of oncology services in Eastern Cape, Limpopo, Mpumalanga, Northern Cape, KZN, and Northwest. We therefore envisage that over the next few years, all provinces will have fully fledged oncology units for greater patient patients and their families. However, these patients must be appropriately staffed and care pathways established as applicable within and between provinces. Longer-term plans for the establishment of more equitably accessible cancer care centers are also being considered, including the notion of public-private partnerships with clear agreements to increase capacity in the private sector. Access to medicines remains a priority. The majority of items on the World Health WHO essential medicines list are available in the South African public health sector, either as EML items or as named patient motivation items. Those items that are not available can be accessed through Section 21 application processes. Further, access to oncology medicines is assisted through the use of generic tendering, use of therapeutic class tendering, and the recent registration of several biosimilar products. Through the continuum of care, patients, families, and communities must receive the full continuum of care, including rehabilitation and fully integrated palliative care in line with the revised definition, which allows for quality of care for as long as possible. While noting delays in the commencement of implementation, the National Framework on Palliative Care facilitates government's responsibility toward comprehensive strengthening of health systems, which are required to deliver a continuum of integrated care, including access to pain management, once again, which is entrenched in our human rights. This is where this initiative of the Pan-African Cancer Research Institute comes in. You have a critical role to play in increasing our innovation throughout the continuum of care and to close gaps that exist in our service delivery model to ensure equity among all our patients. The government appreciates these kinds of initiatives as they fall squarely in our developmental plans. In recent times, Our scientists involved in genome sequencing have demonstrated exceptional brilliance in leading scientific inquiry and discovery during the COVID-19 pandemic. We believe that this research institute, together with your partners, many of whom have presented this evening, will follow in these footsteps and lead in cancer research globally. In conclusion, I congratulate you on the launch, and I look forward to receiving the outcome of the proceedings in the spirit of partnership with you and your partners as we aim to use evidence to leave no one with or who is at risk of cancer behind. I thank you and wish you well. Thank you very much.
Thank you so much, Sandia, for that wonderful message from our minister. And we are truly grateful for the support that is offered by our National Department of Health. And certainly we will keep you posted and provide all the recommendations that are coming out of this meeting. Without much further ado, colleagues, I will just change our program slightly because we are running late. We were meant to have a Q&A session for 20 minutes that was going to be chaired by Prof. Zodwa Dlamini, but it will be remiss of me. We've heard many people talking about this Zodwa Dlamini, and I think that Prof. Dlamini, I'd like to please raise you so that you can come and say just a few words, even if we're not going to have a Q&A. Colleagues, Professor Dlamini, really this is a great honor to call upon you. Prof. Dlamini is the founding director and executive head of PACRI. She's a professor of molecular oncology here at the university, and she's also a scientific director of the prestigious MRC, where the president is Professor Glenda Gray, who just spoke earlier on. And Professor Dlamini is also chair of the Scientific Advisory Board for the African Health Research Organization, a not-for-profit institute whose mission is promoting the advancement of global health through research, publication, training, and community interventions. As I end, I do want to say that Prof. Dlamini is an overseas fellow of the Royal Society of Medicine, and this, colleagues, is an elite group of physicians or scientists who are elected to the Royal Society of Medicine. Thank you so much, Professor Dlamini.
Thank you very much, Program Director. You caught me off guard. I normally think for 2 days what I'll be talking about, but I'm not going to take time. For me, I'm very excited and very emotional seeing you here and people from all over the world who are watching online. I started this initiative well, you had Glenda Gray saying some words about me, but when I went to present it to the MRC, I could see that they were lost and not believing in me. But of course, I knew where I was going, so I had told myself nothing is going to sway me. So I'm here and I'm hoping that we will get support. I'm getting real support from the university, because without the support from the university, and also for the university to get me from where I was to here, nothing like this would have happened. So I'm really depending on the partners. I'm depending mostly on the PACRInians, that is the team, the core team of PACRI, the clinicians, all the oncologists, the pathologists. Also, we have surgeons. At the moment, everybody just comes. It doesn't matter whether we have a lab or not at the moment, because it's being built, but we work together very closely and we're like a family. So I'm hoping that we're gonna remain so, and we're gonna move forward and actually achieve a lot, because this is really dreadful disease like Prof. Kupe is saying. So we're gonna really defeat this cancer because working together is the only hope to fight this disease. Thank you very much.
Thank you so much, Prof. Dlamini. And really, it's not in our African culture if the person who's brought us here, people don't see your face. So that's why I raised it to say, at least let people see you so that when we walk around, even in our masks, we'll be able to say hello and congratulations. So once again, huge congratulations and well done. It's really just an honor. So colleagues, we now come to the closing remarks, and these will be done by our CEO of the Cancer Association of South Africa, Elise Ube. And Elise, incidentally, is an alumni of this university. She did her BA Social Work and her Master of Arts in Social Work with a special focus in community work here at the university. She also has a number of awards, Most Influential Woman in Business and Government Awards, Top Woman Award with Standard Bank, and she was also one of the 5 finalists in Corporate Top Performers of South Africa Business Leader of the Year. And the reason why I mentioned this one is because in this particular category, she was the only CEO of a nonprofit organization to ever reach this position in the 13 years of this award. Over to you, Elise.
Good afternoon. Thank you, Program Director, and good afternoon to all the esteemed guests. All protocols observed. I'm very honored to participate in this occasion, and I wish to extend my gratitude to Prof. Kube and the organizing team of the University of Pretoria for hosting this evening's panel discussions and the signing ceremony as part of the launch of PACRI. And I also would like to give special thanks to all the esteemed panel members and speakers for your very insightful presentations. And in closing, I think my task is really to try and summarize all the main takeaways from the presentations. Now, when listening to Prof. Gray and Prof. Bates, one is just under the impression of the very concerning realities of cancer in Africa. And you would agree that all efforts should be made and all resources should be pulled together to fight this disease, which has the potential to become a pandemic in Africa. The very unacceptable high incidence of cancers burdens the already health systems that's struggling to cope with service demands. In South Africa alone, nearly 120,000 people are diagnosed with cancer annually, and that's only those that we know. It's really an underrepresentation of the true incidence of cancer in South Africa, I do believe. And many of these cancers are diagnosed at a late stage. And these patients can expect to face many challenges, as Sandhya also have pointed out. Sometimes lack of screening and early detection facilities, delayed diagnosis, bed and medication shortages, low access for treatment and medicines, treatment inconsistencies, and then also compromised immune systems due to chemotherapy and radiation treatment. Yes, cancer treatment is in crisis, and unfortunately, government also had to direct many resources towards addressing the COVID pandemic, resulting in cancer patients being left behind. We need to address this dire situation, but research is required to provide the latest evidence on cancer surveillance, prevention, screening, diagnosis, and treatment to inform our policies, cancer prevention and control plans for resource allocation to tackle this disease. Now, long-term collaborative research efforts are needed to eliminate duplications and coordinate optimum investment of resources. And cancer research requires a national strategy for integrated, multidisciplinary, focused approaches to combat this disease. And it's in this regard that I challenge PACRI to take up a leading role in Africa for cancer research. Now, funding streams also need to be strengthened. And of course, we are very, very appreciative of all the business and industries who already this evening offered and their support. But we call on the rest of the industry and business to support initiatives such as PACRI and to enable institutes like this to become world-class research institutes so that we can push the boundaries of precision oncology, cancer prevention, and bringing new approaches for early diagnosis and novel therapeutic agents to improve health outcomes and to reduce the inequalities and strengthen health systems in underserved and social-economic disadvantaged communities. Now, Professor Bates, you've also told us about the value of cancer institutes, and we can count on the support of everyone to make and we want to call on everyone to make your ideas available so that we can make the best of what this new institute can deliver to make a major positive impact on cancer control and on the patients' lives. Now, victory over cancer requires much more than just cancer protocols and research and development of treatments and regimes. It takes a sum of collective. And that is why the strength lies. And that is why it's so appreciated of everyone here who are pledging their support. Now, support to PACRI will enable this institute to deliver on its vision and will certainly not be wasted, but a huge return on everyone's investment. The perspective that was brought to us by Prof. Bowman, that we can count on high-income countries also to partner with cancer researchers in Africa, is indeed encouraging. And I'm sure the outcomes thereof will benefit all globally. We all have the opportunity to embark on the biggest ever action throughout Africa, defeating cancer together. And then also listening to Dr. Trantley and Dr. Reddy and some of the other speakers of industry, there's all reason to be very hopeful about the future of cancer research. There are so many promising advances that are transforming the way we think about cancer and delivering new treatment approaches. Joan Massicou, director of the Sloan Kettering Institute and a very prominent cancer researcher, once said in an interview on the future of cancer research that we eventually can develop a relationship with this disease, cancer, that will be much more like the one that we have with infectious diseases, for which we have antibiotics and other treatments. May that be soon the case. I'm very positive that we will become stronger through our exchanges and collective learning opportunities through our collaboration with this new institute. Cancer is also privileged to be a partner, as we always had a heart for supporting cancer research. Cancer is the only non-profit organization in South Africa conducting cancer research. And we have a proud portfolio of research over the last 20 years, because during this time, cancer was one of the biggest, largest local funders of cancer research. We supported over 255 researchers from 12 educational institutions, which were funded by cancer, and we've managed over 110 projects that resulted in 302 publications. I wish to congratulate the University of Pretoria, specifically Prof. Dlamini, for your initiative and with establishing this new institute. We are looking forward to work together with you. We're looking forward to defeating cancer together. My best wishes to everyone. Thank you.
Thank you very much, Elise, for that heartwarming and as etiquette says, you never repeat anything that is said in closing remarks, because that's what they're for, to close. And so this then closes, colleagues, our first part of this program, and our second part then will be the signing ceremony for the partnership agreement, which will be chaired by our Vice Chancellor, Prof. Gupe. Prof. Gupe, I don't know if you want to come and say a few words on the second part, or I just close the program. Thank you very much. So as it is with agreements, colleagues, especially at this late hour, Professor Gupe and colleagues, from all our partner institutions will be doing the signing once again. Thank you so much for joining us this evening. It's been a great honor for me to chair this first session, and also congratulations, I heard a new word, to all the PACRInians. And we wish Godspeed to this wonderful institute and program, and thank you so much. Good night. So colleagues, just to say that it's un-African to leave without feeding people. So after we have signed, please have a bite to eat. And if you don't want to eat, put it somewhere and take it home with you. Thank you. Let me get